Hello, this is going to be a tutorial video on visualizing high-dimensional spaces. You might have heard that to imagine a four-dimensional space, you should start with a three-dimensional one. And I'm going to draw the little carets that represent right angles. There's a right angle between each pair of axes. That to visualize a four-dimensional space, what you should do is start with a three-dimensional one and then add another axis that's at 90-degree angles to all of the existing axes. So something like this. Something like that. This is not what I'm going to be talking about. It's true that that works, that is accurate, but it's not the best way that I've found for actually visualizing what's going on in these spaces. So let me start off by saying that a better way is based on the mathematical notion of a fiber bundle. That's where you have a base space, and at every point of the base space you have a branch space coming off. So let's take a simple example. Let's use a one-dimensional line to visualize a two-dimensional space. So let's start with one dimension. We want to visualize two dimensions, and we already have one, so we need one more dimension. So at each point of this line, we're going to imagine another line coming off of it. So at each point there is another line. This is now a two-dimensional space. For example, let's say you want to refer to this point. It's at this position in the base space, and then it's at this position in the branch space. So it has a coordinate in the base space, and then on top of that, it has a coordinate in the branch space that's coming off of the base space. Now, the same can be done for 3 and 4 dimensions. Let's say we want to imagine 4 dimensions, a four-dimensional space. What we're going to do is start with a three-dimensional space and imagine that at each point there's a line. At each 3D point there is a line attached, hanging off of it. So if you want to talk about a point in four-dimensional space, you first have to specify the point in the 3 dimensions of the base space, and then on top of that, you need to specify where along the line it is. Now, this is one way to visualize a four-dimensional space. Another way is you could start with a plane. You could say, we have a plane here, and then at every point of the plane, there is another plane. And here there's another plane. Maybe I should have drawn the axes instead. And here there's another plane coming off, and at each point there's a plane. So to specify a point in 4 dimensions, you first have to specify where it is in 2 dimensions, and then you need to specify where it is in the branch space. So this works for higher dimensions too, higher than 4. For 6 dimensions, for example, you can start with the base space as regular 3D space. And then for the branch space, have another 3D space. So at this point we've got a branch space, and at this point we've got a branch space, and so on. Now, every point has the same branch space. So by the time you've specified where a position is in the base space and where it is in the branch space, you've totally specified its position. And every branch space is the same. So visualizing 6 dimensions is as easy as visualizing 3 dimensions twice. Because all you need to do is locate a point in the base space and then locate a point located in the branch space. Like, let's say we have an object that starts here in the base space and here in the branch space, and in the base space it follows this path, and at the same time in the branch space it follows this path. Then we've totally specified its path, because at each point in the base space there is a branch space, and these are the points that they're in for each of these branch spaces. So, another thing that you can consider, you can do, is kind of like we discussed above for the two ways that you can visualize four dimensions that I discussed. You can also, the branch space and the base space, like there's no one set of axes that's better than any other. So you can say, I want to take the x-axis of the base space and make that the z-axis of the branch space, and take the z-axis of the branch space and make that the x-axis of the base space. You can swap these things around and rotate them however you want. There's no one preferred choice of base space and branch space. But nevertheless, it's a good way to visualize things. This also works for things that are not planes, even though I've only talked about planes so far. Like, you can have a space that is just like 3D space, except at each point you can also have a coordinate that's somewhere along a circle. So you can have a little tiny rolled up dimension that's hanging off of 3D space. And this is exactly how you should think about it when they talk about that sort of thing in string theory. So let's say we have this kind of space. It's like 3D space, but then there's a little tiny rolled up dimension. So it makes a sort of cylinder. This, you can imagine this just as easily as 3D space plus a circle. So imagining this weird four-dimensional sort of cylinder-y thing is as easy as imagining 3D space plus a circle. So do that. And it would also apply if instead of a circle, maybe you had a sphere at every point. Maybe you had this as your little tiny rolled up dimension. Maybe it's a sphere and not a circle. But this is identical to imagining 3D space plus a sphere. So just imagine 3D space and a sphere at the same time. That's as easy as imagining this 5-dimensional space. Now, one thing that I have not gone over is how to imagine an actual higher dimensional sphere. Like, this alone doesn't exactly get you everywhere. Imagining a higher dimensional sphere is a little more complicated. I might go over that in the sequel. But until then, see you next time.